All right. Good morning. This is Tim Stewart. I am president at Visual Decisions, and we are here today to talk about augmenting operator performance with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes have to be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt those processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. And as part of that, if we look at the operator, we want to figure out how can we make that operator's life easier, better, et cetera. And so what we'll be talking about today is augmented operators, or augmenting operations to make that life for the operation or for the operator more simple. So as a quick procedural note, if you have questions during the presentation, please enter them into the Q&A and I will get to them at the end of the webinar. So with that, a quick definition on what we mean by augmented operators. So we've got the human being over here on the left, and then we're supporting that person with human-centered process design and Industry 4.0 solutions. What we mean by the human-centered process design, in case you missed last week's webinar, is really everything from the workstation design, the ergonomics, the computer user experience, things like that. All of those things factor into that process design that is really centered around the human at the middle of the process. And with the Industry 4.0 solutions, we'll spend most of our time going through that today, since we went through the human-centered design last week. If you're interested in that presentation from last week, there is a recording up on my webinar, and if you shoot me an email at the end of the presentation, I'll reply with a link to that presentation. So how did we get to where we are today? And going back all the way to craft manufacturing, Frederick Winslow Taylor really broke that down into scientific management, where you took the overall task, you broke it down into the smallest possible steps, and then you had people just repeat those steps all day long. And as I note on the slide, it's really an early attempt to put robots into the plant before robots existed. The idea is that you just want to make that as repetitive as you possibly can, so that the worker can get as skilled at it as they can. Unfortunately, it's really dehumanizing. It is a horrible work environment. You have repetitive stress injuries and so forth. Plus, it's just doing the same manual one movement over and over again for 8 hours a day. Just not something that anybody wants to do anymore. So Toyota came along, as well as some other companies, but Toyota's the one that gained fame for it, and really changed everything with lean manufacturing, or the Toyota production system. And at the heart of that, there's a quote from Taiichi Ohno, the father of lean manufacturing, that says the real objective of the Toyota production system is to create thinking people. And this is in direct opposition to Taylorism, which wanted to take all thinking away from the worker and give it to management. With the Toyota production system, the goal was to empower that worker as much as you possibly could to be the center of where everything happens. And then everyone else just was working to support those people. And the ideas behind this, Just using TPM, or total productive maintenance, as an example. You have autonomous maintenance, which is, basically giving the operator the responsibility for doing the basic maintenance on the equipment. Focused improvement and having those operators be a part of the overall improvement effort, whether it's, just collecting the data in the first place or even acting on it as part of the team afterwards. Planned maintenance, and having that operator interacting with the maintenance department to make sure that all of the information gets captured that everybody's going to need. Same thing with quality maintenance and so forth on down. Really the operators at the center of all this, making sure that all the data is captured. You have the basics done, whether it's the autonomous maintenance or the 5S, and there's a lot of responsibility being pushed down to that lowest level. So with all of this responsibility, unfortunately, the operators didn't always get the tools that they needed to make the best decisions on the front line. As they're there, they don't have a lot of visibility to upstream or downstream processes, to the greater business context and so forth. And so they're really making very localized decisions. And so how do we give them information about how what they're seeing in front of them fits into that bigger context of the business, and give them the information that they need to really make good decisions, not to mention just do their jobs more effectively. And so there's a few technologies that I'm going to focus on today. One of them is the Industrial Internet of Things. And if you're not familiar with it, what this does is it provides connectivity, event processing, communication, persists the data, has very agile development capabilities so that you can put customized screens and workflows in place, and allows you to really get that information from the shop floor and utilize it within the different processes in the way that makes most sense. And we'll give some examples later on. Augmented reality, not rugmented reality, as I noticed is in the picture, is a really fantastic tool for helping out the operator in so many different ways. And we'll go through a lot of those as we proceed. But one of the things I wanted to talk about is that with I-IoT, with some of the other technologies, predictive and so forth, that we'll discuss, they're really extensions off of existing systems. We've had MES for a long time. IoT is a different approach, but you're still gathering that data and so forth. Augmented reality is really kind of a brand new set of capabilities that we have within manufacturing that just haven't been there in the past. And it's really exciting to me, as someone that's been in the industry for a long time, to have what is really this brand new tool to utilize out on the shop floor and really drive a lot of different efficiencies. From a business intelligence perspective, as you look at I-IoT, it does a great job of presenting what's happening right now, and putting that within the context of recent performance. If you want to look at performance across time and within a much greater context and so forth, the BI tools are very good for doing that. And then the artificial intelligence and machine learning capabilities that are being built into so many different things these days. But in particular, for instance, the IoT solutions have these capabilities built in that allow you to take that information that you're collecting from those different data streams out on the shop floor, and now utilize that to do automatic classification of issues, to identify the issues in the first place, to be able to predict when those are going to happen, and then notify somebody in advance. And that somebody is usually going to be the operator. So how can we make the operator's life easier by them not having to really focus on the details of current performance metrics and so forth, and utilize these systems to give them those warnings when things are about to slip out of control. So what we'll get into next are some of the use cases for these different solutions. And one of the first ones I'll talk about is augmented remote assistance. And what this is utilizing, a phone, a tablet, the glasses, if you have them, there, being able to have the operator get questions answered, and being able to give the expert on the other end, visibility to what's happening at the station. And the idea with this is, for instance, if you have a machine stoppage, instead of calling for the maintenance crew, the engineering staff, and so forth, and waiting for them to come to the machine, you can actually start this remote assistance, and wherever they're at, they can look at their phone and see what's happening at the machine, and perhaps give that operator remote assistance to let them handle that without having to have somebody come out to fix the machine. And so you're really giving that augmentation of all of those different capabilities within the business to that operator at the point of use. Digital and augmented work instructions are fantastic. I can't emphasize enough how much it helps a worker when compared to especially the printed page, but even having these work instructions on a computer screen is completely different. Because if I'm, kind of focused in my task and I'm absorbed in what I'm doing, and I've got the piece in front of me, and maybe it's a new build, maybe it's something I haven't done very often, maybe it's something where, this is a task that I'm kind of subbing into for the day, or I'm just doing my cross training and so forth. Being able to have that visualization in front of me using the glasses makes my learning curve so much faster, as opposed to being there kind of focused on my task, taking my focus away, shifting over and looking at either a computer screen or looking something up in a set of work instructions, and then shifting my focus back and kind of getting back into where I was in the task. If you've ever been reading a book and somebody interrupts you, and you take your focus away from the book, and then you come back to the book and you're like, okay, where was I at? It's that same kind of experience for an operator every time that they have to look away from the task to go to the work instructions. And so by having these things right there in front of them as they're looking at the task itself, you can reduce your downtime, your scrap, your error rate, and so forth, not to mention your training costs. And so really fantastic capabilities with this new technology. From a connected work cell perspective, operators are relied on so much these days for tracking information about so many different things. And being able to provide kind of that seamless experience where you have that IoT solution that is grabbing pretty much all of the data that is required, and then feeding that into these other systems, so that those work instructions that we were just looking at, for example, on the glasses, those glasses know exactly what item is being built, because you have the IoT system that's communicating with either the device or some other system that is pulling what is the current SKU in front of me, and what are the work instructions for that, and I can feed that into the digital work instructions in the AR system. And so tremendously powerful connectivities here when you have these different solutions in place. And all of this is really centered around, again, that operator, so that what we're doing is we're just breaking down the barriers to that operator's productivity. So whether it's learning something new, having the instructions right in front of them, not having to record every single piece of information that flows out of the machine, automatically tracking different things, and doing all that error proofing and poka-yoke and so forth as well. So in terms of the asset monitoring and utilization, being able to see what that current status is and so forth, and if something happens on the machine, being able to notify others immediately that that operator needs assistance, and being able to again, provide the larger context of what's happening is, very helpful to that operator as well. I've been in, a tremendous number of situations where, operators are required to maintain tick sheets for, any downtime reasons, for quality issues and so forth. They're, keeping logs and so forth of everything that's going on. And it's, so much more effort for them to have to manually write all of those things, not to mention, within, an overall work environment, having to have a place for, those things that you're recording this information on and having it not get damaged or lost, et cetera. If you just have, that one screen that has all of these capabilities there, much easier. The real-time production performance monitoring, and this is getting more into the details of what's happening within the machine itself. And as you start to look at what the operator can do, they're not capable of, being a data historian and so forth. They can look at some of the outputs and so forth. They can see the alerts or alarms. They can, see when downtime happens, but it's impossible for them to track the millisecond by millisecond performance of the machine and be able to, then record that information. And so this data becomes extremely useful for multiple purposes in terms of, let's say that I have a downstream warranty issue and I want to be able to see what was happening as that part was produced. I can actually, with these systems, track all of that information of not just was, the max and the min within tolerance, but I can see, where it was, what was the shape of that curve, how close did it come, how much time did it spend in different states and so forth. And that allows me to then, run those correlations and start to see what are the factors within production that actually impact what ends up in warranty and what doesn't. And that's just one simple example of how to utilize this information. Quality is another one. So if I'm looking at, what pieces will need to be inspected, instead of just inspecting every 25th piece or something like that, if I have these measurements and I'm able to correlate those measurements to things that might end up in, with quality issues, I can start to, identify, particular pieces that I need to do a manual inspection on. Another, great use for that detailed data is with predictive maintenance. And, as we talked about earlier, being able to have that decision support. So, a big part of lean, a big part of TPM is, kind of pushing that responsibility and accountability as close to the point of work as you possibly can. And with that, you want to make those decisions close to the process. You have to understand the context of the decisions, have the information available, have it be timely, have it be cleansed, and then, have that automation for the analysis of that data. Because that's definitely something that we don't want to count on the operators doing in real time. But if we can, automate that process for them, that lifts a significant burden from their shoulders. Even, something as old school as statistical process control, and being able to, automate that process, removes a certain amount of math and everything else from the shoulders of that operator. And we've had systems that can do SPC, at the station for a long time, but being able to have that capability integrated into all of this other analysis, being able to correlate what's happening with your SPC data with, the process variables that we're pulling from the machine as it's producing parts and so forth, are tremendously powerful capabilities. I talked about the glasses earlier. Another example is vision picking, and being able to not just see the work instructions, but actually highlighting, what are the bins that I'm supposed to pick from for this particular build that I'm working on. And, this is so effective for reducing error rates for assembly. When you can not only highlight the bin that they're supposed to pick from, but actually track which one they pull from and how many pieces they pull, and understand, what is the bill of material for the current build and so forth, and being able to tie all of those different things together just gives you so much in the way of error proofing and reduction of error rates, and just speed of this also, because if that, I just automatically reach for what's in the green bin and it tells me right there, how many I'm supposed to pick and so forth, and it just makes it easy. So another good example of, these tools. From that autonomous maintenance perspective, the operators have a lot of responsibility around this for plants that do TPM, lean, et cetera. And, they have to be able to track the counts since the last PM activity, and for each different PM activity hits since the last tool change, in terms of that maintenance schedule and so forth. You now have the ability to utilize the data, and this isn't done by the operator, but being fed to the operator. What is that optimized maintenance schedule? How long can you go between oil changes and things like that? And it just gives you that ability to then feed to the operator. Today, you need to do these tasks. Because that tracking is done automatically, the operator doesn't have to do all of that himself. They're not counting on the operator from the other shift being accurate in their counts and so forth. But you have all that information right there. You get that task list at the beginning of the day of what are my autonomous maintenance tasks that need to be done today. In terms of optimizing that schedule, you also have the capability of utilizing some of these condition-based or predictive capabilities to run until you almost have a failure. So for instance, we're looking at grinding wheels in one particular customer of mine, where we are predicting when that grinding wheel is going to start producing bad parts. And in the past, they would replace that grinding wheel after a certain number of pieces, but now we can actually run it until just before it starts producing those bad parts. Or you can run until some other type of performance change and so forth. Being able to get notifications automatically for being able to do that automated tracking instead of tracking things by paper and pencil. Automated messaging and alerts so that they walk up to the machine and see what they're supposed to do that day. And then, even having the potential to lock out until a task is completed, but also track, which tasks are done automatically as well. I have a very long series of presentations on how we take operational excellence and blend that with Industry 4.0 capabilities, but I'm going to hit a few highlights here that really pertain to the operators. So, as we look at this new world of work, we really have to look not just at the technology, but the process and the people as well. The analogy that I use all the time is a Fitbit, where I've been wearing a Fitbit for a long time now, but I haven't lost any weight. And the reason is not the Fitbit. The Fitbit works fine. It's really me. I'm the problem here. I haven't changed my behaviors, and therefore I haven't lost the weight that I was kind of expecting. And it's the same thing on the shop floor. The technologies work. I mean, in just about every case, the technologies that you're going to buy from these vendors, they work. What you have to understand is how you actually build your process around that technology, or utilize that technology, use those enablers and capabilities, and tie that into the process that you have in order to really take advantage of that. So something as basic as standard work, as you think about the operator and the standard work that they're doing every single day, how does Industry 4.0 and how do the technologies that we've talked about really help with that? Well, first of all, it's not just delivering the right information to the right place at the right time. It's also easing the collection of that information as well, which the operator has a significant responsibility for today. And if you can automate that, that's one type of waste that you can remove from the process. Augmenting the people in the organization with new capabilities, we've kind of beat that one to death. Encouraging the adoption of new and standardized work practices. So if you can imagine, having these glasses, and especially for the millennials or generation Z in the crowd and so forth, they're going to be a lot more enthusiastic about adopting those new work practices when they can get trained using this cool new technology. I talk a lot about making manufacturing fun again, and how do we do that? And that's one way that we can go about that. And then when there are deviations from those work standards, how do we detect that, and how do we elevate attention to it and provide that feedback to the operator directly, as well as the supervisors? And so those are some of the other capabilities that we have that can help, where Industry 4.0 can really help with adoption and compliance to the standard work. Visual controls are kind of always an interesting discussion in a lean manufacturing shop. There's a strong belief that they need to be manual, and that they're much more valuable if someone's up there with a marker, dry erase marker, writing on the whiteboard, or printing things off of Excel and putting them in the little plastic containers and so forth. I don't really buy this. Not anymore. There's a great book, Creating Lean Culture by David Mann, won the Shingo Prize and everything else. But it was made written back in the early 2000s. And at that time, there was a really strong argument that the manual controls were much better than what IT could provide at that time. With these new technologies, in particular IoT, these systems really have the capability of delivering those visual controls where you're automatically collecting the data, where you are delivering that data instantly, anywhere it's needed, in whatever format is going to be most appropriate. And you have the flexibility with the agile development capabilities that these systems have to really rapidly adapt those as you want to change them. And so other than the level of investment of a whiteboard versus one of these systems, I really don't think there's any advantage to doing things manually anymore. We talked a little bit about the improvement process when I showed the TPM slide and so forth. And if you look at Kaizen and the general continuous improvement process, the operator's involved with quite a bit of this in terms of identifying the problems and being on the team that helps it to analyze those and create solutions and so forth. And a lot of this is based on the information that historically that operator has collected at the line. And by automating a lot of this, we really help to not only make that easier and make the Kaizen more effective, but we can shift the focus away from the data collection itself and to the analysis. And if the goal, as Taiichi Ohno said, is to create thinking workers, just by rote writing down everything that's happening isn't really creating a thinking worker. But if we can involve them in that analysis process, that really meets Taiichi Ohno's goal. So some closing thoughts. There are so many opportunities. I only touched on kind of a fraction of them to really make the life of an operator much easier, much more productive, and much more fun than it used to be. And by integrating some of these lean concepts, by integrating some of the human-centered design things that we talked about last week, and a lot of these different technologies that can really revolutionize how you actually interact with the process itself, you have opportunities today to both raise productivity from a business perspective, but also just improve the quality of life for the people in the organization. And so with that, if you have questions, you can put them into the Q&A at this point, or you can email me at tim@visualdecisions.com, or just give me a call at 630-957-8096, and I'm plenty happy to talk to you. I'll probably be reaching out to you to follow up on the presentation. And so I hope to talk to you soon. Thank you.